What's going on, everyone? Welcome back. Patrick here, and moving on to the next question. You feel there's a greater proportion of students in the Ryerson business program who want to go into finance versus the students in the U of T business program. You want to test your claim at a 5% significance level. From a sample of 54 Ryerson students, 21 are going into finance. From a sample of 68 U of T students, 18 are going into finance. What is the conclusion? So, first thing, notice with this question, we are dealing with proportions. And we're dealing with proportions from two populations, right? From the Ryerson business program and then the U of T business program. And just like with confidence intervals and just like with one sample hypothesis testing, when you're dealing with proportions in two sample hypothesis testing, you're going to be doing a z-test. Right? So you're always going to be using the z distribution when you're dealing with proportions. So let's start off by creating a null and an alternative hypothesis. So what are you testing for? You're testing whether there's a greater proportion of students in the Ryerson business program going into finance versus the students in the U of T business program. So if we let pi 1 represent the proportion of all of the Ryerson students going into finance, we're testing for whether there's a greater proportion of Ryerson students versus U of T students. Right? So pi 1 represents the proportion of Ryerson students going into finance. Pi 2 represents the proportion of U of T students going into finance for the whole population. So if this is the alternative hypothesis, then the null hypothesis is going to be the opposite of this, like that. And notice because we have this greater than sign here in the alternative hypothesis, we're dealing with a one-tailed test, right? And more specifically, a right-tailed test. So with proportions, what we got to do is we have to find out what those sample proportions are. So we'll call them P1 and P2. And if you remember, the proportion formula is basically the number of observations out of the sample size that share some kind of characteristic. So here we're dealing with Ryerson. Notice that we sampled how many Ryerson students? 54. And then 21 are going into finance. So 21 out of 54, that's the sample proportion from population 1. And then this is going to represent U of T, so it's going to be x2 over n2. So 18 over 68. And if you want to get the decimals of these, this would be 0.3889. This would be 0.2647. Right? Kept it to 4 decimal places because we're going to be plugging these into the test statistic. So we want it to be as accurate as possible. So we're actually going to do this question in 2 ways. We're going to do it manually, and then I'm going to show you how to do it with the calculator at the end. Now, with two sample proportions, we actually have to calculate something called a pooled proportion. Right, I'm going to maybe symbolize it as P hat. Right, so very similar to pooled variance. Remember when we did a pooled variance t-test, we had to pool the variances together from both samples. Same thing with proportion. We have to pool them together in a certain calculation, and then that P hat we're going to be using in the test statistic calculation as well. And the formula for it, it's very simple. It's just x1 plus x2 over n1 plus n2. So we could get that from here, right? So x1, x2, it's those observations from both that share that characteristic. And then n1 plus n2 is just the sample sizes added together. So 54 plus 68. And when you do that in your calculator, you'd end up getting 0.3197. All right, so that P hat, I'm going to write on the side here, 0.3197. We're going to be using that in the test statistic calculation. Now, let's draw a diagram. Let's find the critical value first. Notice that this is a one-tailed test. So this is a Z distribution. Remember, we're doing a Z test. And what is the significance level we're working with? We're working with a 5% significance level. So this here is 5%, and we're going to be rejecting the null in that area. And then over here, we're going to be accepting the null. So this is 95%. So if we reject the null hypothesis, it means that there's evidence pointing towards our claim that there is a greater proportion of Ryerson students going into finance versus U of T students. And you could look up that critical value in the table. You could also do it with the calculator here. You'd go through these inputs, right? So we're dealing with a Z distribution, a normal distribution. So data would be variable. The tail here, you could pick either the right tail or the left tail. I'm just going to work with this right tail. Area of the right tail is 0.05. Standard deviation is 1. And then the mean is 0, right? We're dealing with a Z distribution. So when you execute that, you'd end up getting 1.645 for that critical value. Right, so we got the critical value, we got our critical region, we got our acceptance region. And now what's left to do is just to calculate that test statistic. So we're dealing with a Z test statistic. And the formula for it, when you're dealing with two sample proportions, is basically P1 minus P2, right? The difference between those sample proportions here, all over the square root of P hat times 1 minus P hat times 1 over N1 plus 1 over N2. Right? That's the formula for proportions. So that's where that P hat is being used. Sometimes you'll see in certain textbooks, they'll have like the difference. They're going to be subtracting the difference in those population proportions, but that's always 0 anyway, right? You're going to see when we input all of this in the calculator, when we're calculating this hypothesis test, there's no input for that right there. You're only going to be inputting that. So you never have to really write that. Basically, you can just forget about this. It's always just P1 minus P2. So plugging everything in, you'd get 0.3889 minus 0.2647 all over the square root of that P hat, 0.3197, times 1 minus 0.3197, times 1 over the sample size from the first population, so 1 over 54, plus 1 over 68, which is N2. And when you do that whole calculation, you'd end up getting 1.46 in your calculator. So where does 1.46 fall in this diagram? Notice it's to the left of 1.645. It's right here. And so we are accepting that null hypothesis, meaning that there's not enough evidence pointing towards our claim that there is a greater proportion of students in the Ryerson business program going into finance versus the U of T business program. And if you want to do this whole test in the calculator, you'd go through these inputs here. So you'd have stat, F3 for tests, F1 we're doing a Z test, and then F4 because we're dealing with two proportions. And then you would end up getting over here. So this P1 input, it's always this alternative hypothesis. So you basically have a greater than sign of P2. So instead of representing the population proportion with pi's, the calculator represents it as P1, P2. This is not the same as this P1, P2. Maybe I should put like a bar here, right? Just as a heads up. All you have to know for this is basically what sign is here in the alternative hypothesis. If it's a greater than sign, you put in a greater than sign there. Now, X1, 21, N1, 54, X2 is 18, and then N2 is 68. And then when you execute that, you would end up getting a z-score, or a z-test statistic of 1.46, what we got before. You'd also get a p-value of 0.072. And also, if you want to get that p-hat quickly without doing that calculation we did before, this output also gives you that p-hat. I think it's at the end. If you scroll, you'll see 0.3197. But these are the two most important right here. So 1.46, notice it falls there compared to the critical value. Continue to accept the null hypothesis, fail to reject it. Or you could look at the p-value, 0.072, compared to the significance. And whenever the p-value is greater than the significance level, that means that we fail to reject the null, or we continue to accept it. Right? So the conclusion of this question is that there's not enough evidence that there's a greater proportion of students from the Ryerson business program who want to go into finance versus the proportion of students from the U of T business program who want to go into finance.